Dear aspirants, this is Dr. Sourav Sir's classes. Our contact number is 98367 93076. Again, I am repeating our contact number, which is 98367 93076, and our email ID is soravsirclasses@gmail.com. So, if you have any mathematical queries, doubts, or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID, then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations like ISI, CMI, TIFR, NBA, HM, CSI, and NET get that kind of examinations. And this question is appeared in the ISI JRF question paper, and the question is telling us that for n greater than equals to 1, define fnx equals to n square plus n square by n square plus x square for all x belongs to R. Prove that the sequence of function fn converges uniformly on bounded intervals, but fn does not converge uniformly on R. So how can we do that? So we analyze the uniform convergence of the sequence of the functions which is given to us as okay, and our x is belonging to R. So now the we are going to find the pointwise limit of given sequence of function. So fix any. So now for x equals to 0, our fn0 is equals to n square upon n square plus 0 square. So that will be n square by n square, that is equals to 1. And now for our x not equals to 0, what can we do? Then we can have our fnx equals to n square by n square plus x square. So we can divide the numerator and denominator both by n square. So then we will get 1 by 1 plus x square by n square. Okay. So as our n is tending to infinity, we would have what? Our x square upon n square will go to 0. So fine, so good. So then we can write our fn x is equals to 1 for all x belongs to R. Okay. So thus our fnx converges pointwise to the constant function fx equals to 1. So now let us think about the uniform convergence. Let us check first in the between the interval m minus m to m. So to check uniform convergence on minus m to m, we have to consider the supremum of this first. That means supremum x belongs to minus m to m. Then we would get fn x minus 1 mod equals to supremum x belongs to minus m to m, and that will be what? Sorry, 1 plus 1 by x square by n square minus 1. Okay. So now rewriting it in another form, we would get mod of fn x minus 1 is equals to 1 by 1 this thing, sorry, 1. So now it's correct. So that is equals to x square by n square upon 1 plus x square by n square. Okay. So since our x belongs to minus m to m, the maximum occurs at only at plus m or minus m, x equals to plus m or minus m. So now supremum of this, when our x belongs to closed interval minus m to m, our mod of fn x minus 1 will be what? M square by n square plus that will be this. Okay. So now what can we say? That for large n, our this thing will go to, for large n, this thing will go to this, and that will be 0. Since the bound is independent of x, it follows that our fn goes to 1 uniformly in the bound. That means we can write on minus m to n. That means a closed bounded interval. So now we are going to think about the uniform convergence on R. That means the whole set of real numbers. Okay. So now what can we get? So now let us take the supremum when our x belongs to R, fn x minus 1. So now for large x, we approximate our fn x equals to 1 by 1 plus this thing. So now choosing x equals to n, we obtain f of this thing, f of n is equals to 1 by 1 plus n square upon n square. So that will be equals to 1 by 1 plus 1, which is 1 by 2. Okay. So thus our mod of fn n minus 1 equals to 1 minus half. So that will be half. Since this bound does not tend to 0 as n tends to infinity, uniform convergence fails on R. So our fn x converges uniformly on any closed bounded interval minus m to m, and our fn x does not converge uniformly on R because the supremum deviation from the limit function does not tend to 0. So thus the result is proved. Okay. So now again I am telling that if you have any other mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange it out clearing session for you. After that, you can join our regular batches, our one-on-one sessions and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay. Hope you understood, guys. Thank you.